Hello, my name is Heiko Seitz, technical author here at IDS, and welcome to my session in our Vision channel. Today it's all about the new exciting features for our next generation AI-based system, IDS Next. With the coming software update, we will take a whole new look at AI-based application development. I will show you the new possibilities that will enable everyone to not only create their own individual AI vision application quickly and easily, but also to deploy it directly on an IDS Next camera. For this purpose, we will take a look at the entire workflow together by creating an AI vision application. Before that, I would like to briefly review the system and explain our motivations, what we're trying to achieve with the new software update, who is it intended to help, and of course, what you can do with it. The IDS Next hardware are smart, intelligent cameras with industrial quality, suitable for edge use, as they are able to process vision tasks independently on the camera without a PC and generate results. For this purpose, they have their own IDS AI processor based on an FPGA, the Deep Ocean Core, which can execute neural networks hardware accelerated in the camera. Application processes are realized via vision apps, which can be exchanged quickly and easily, similar to a smartphone, and via standardized interfaces such as IOs, serial connections, Ethernet, and software-based protocols such as REST, OPC UA, or even a customized one. The cameras communicate, for example, inference results to PCs, PLCs, and other external devices or machines. All in all, they are intelligent cameras, as there are already several others on the market. But what makes our system different from the others? Good question. Correct, because this is where our idea of simple AI vision comes into play. We made it our mission to that everyone should be able to create their own AI-based image processing. And for this reason, in addition to the hardware of IDS Next, we offer a completely self-developed software environment that covers the entire workflow. The creation or training of a neural network through images with a suitable categorization of the image content, as well as the realization of the application software that later performs the inspection task on the edge device, on which the application works in a fully optimized and autonomous way. It should be also mentioned how easy it is to maintain and evolve the application. And if you now perhaps think that you do not have the necessary expertise for any of these steps, then IDS Next is exactly the right system, because for none of these steps you need a special knowledge in artificial intelligence or application programming. And how this works? Imagine an edge system where you no longer have to program in a classic platform-specific way with a direct device connection, because the basic device functions would be pre-programmed in a universally configurable modular function kit and therefore do not have to be reprogrammed or cross-compiled each time. And for training the machine learning algorithms, we already have an easy-to-use CNN training tool in IDS Next Lighthouse. What would then still be missing is merely a description of the application workflow. And that is how functions have to be combined with each other. But also for this, you do not be familiar with a special text-based programming language, because we have now integrated all of this together in Lighthouse as the only necessary development systems. And with such a high-level development environment, you neither have to deal with platform-specific programming nor with the special syntax of a programming language. The complete AI-based embedded vision development now takes place in the cloud, in this cloud-based service. This allows you to fully concentrate on what your application should do, which will later be executed in the camera. And how you do describe the workflow on an IDS Next Vision app. Here too, we offer different approaches that on the one hand lead to the goal quickly and easily and simple as possible and are very application oriented, or on the other hand offer a little more freedom in the design but require a little more overview and knowledge of the device functions and what you can do with them. So the Use Case Assistant offers a selection of ready-made use cases for an easy start and guides through the entire process of app creation with simple queries and tips. Without any special knowledge of whether objects needed to be detected or classified, it prepares the right application components for you in the background to find the desired objects, count them, and make the results available via the selected device interfaces. It asks you for images according to the selected use case and explains how to label them. IDS Next Lighthouse then creates the datasets with annotations from the images and also the necessary training project for a neural network. In just a few steps, a complete embedded vision app is created in the cloud that you can run directly on the camera, IDS Next camera. In this way, many simple use cases can already be completely covered. However, for some more complex processes, such as this two-stage analysis by fruit type and quality, which then requires several neural networks, you don't have to switch immediately to C++ or another text-based programming language and leave the comfort of IDS Next Lighthouse. And for this purpose, we have developed a block-based visual code editor that uses Google's Blockly library and with which processes can be combined like puzzle pieces to form sequences for any complexity. In this way, we enable a much higher flexibility of the application description, while at the same time making the process easy to follow. Thanks to the intuitive user interface, even beginners can use it to quickly create completely customized sequences. So variables, parameters, and AI results can be easily connected through logical links with mathematical calculations and conditional if-else statements, or recurring actions through loops. It is also possible to use several neural networks in one sequence, as in this example. Here, an object detector provides a basic pre-sorting of the different parts. Here in this case, the parts are fruits, apples and pears, followed by a detailed error analysis by a second classifier to categorize the parts even more precisely. Such procedures are otherwise only possible with the Vision App Creator and programming knowledge in C++. But enough of explanations. I would like to introduce you the new possibilities of embedded vision development with a very simple application example here live. For this, let's just take a look at the whole workflow by creating a vision app together that is able to detect gears. I have some of them here under my camera, and then we can start. So the first thing we have to do to create our vision app is to log into IDS Next Lighthouse 2.6. And we arrive directly in the new tab of Vision Apps, which is at the beginning normally not containing any projects, but the Gears Detector app I've already created here in order to save some time, but we'll go through the most of important points together now. I've also created some data sets of and with images from Gears, using the familiar Lighthouse functionalities, and I also trained a neural network calling the Gears Detector. So we can now start directly with the app, creation and already use these components. Go back to the Vision app tab and open the created program. I give it a descriptive name and a nice thumbnail, and then we jump directly into the program code. So for our really basic app, we does not need any initialization work and could start directly in the main loop, which is running through each camera image, and we first get a variable here for the current image we want to work with it. After that, we use the detection analysis block with a detection threshold of 75%. And you can also see that no CNN is actually set. That is what we do together now. So for that we go into the Objects tab, see in the Neural Networks folder, and can see that we have already pre-trained and prepared a CNN, and we activate one of them to be included in the Vision app code. So, and then in the next step we can also collect this for the analysis here. Next thing we have to do is to draw the results of the detection as ROIs in the camera image. This way we can later also see visually what the detector detects. And finally, we prepare the detection results in a nice text for the app interface, for the GUI, graphical user interface, and display the results in the last step of the image and of the text. And that's it. With this, a first process workflow of our really small application workflow is completely described and ready for a test. So at this point, we want to make sure that the app is running when we download it and put it on the camera. But what can we do? We are still in the cloud and we have no cameras active here. So the possibility is to go in the Object tab, and here in the camera we have the possibility to upload some images that we could use in the Vision app. But it's really more easy to use a data set that we just prepared before in Lighthouse. We just see them here. We choose the Gears dataset, where we have really some good images with objects and also including some gears. We use this, go back to the code and run the Vision app. And what we can see here in the debug part is how the app is running and detect and analyze the images and find some gears. 1 gear, 8 gear. So seems to run. Good. We just stop it here and go to the compile. So we prepare the app for the download and to run optimal on the camera. We doesn't have to do something here and create a Vision app. We see here the process is running. We produced a Gears detection app 1.1 and download it from the cloud. So the next thing we have to do in our complete workflow is to upload the Vision app into our camera. So what you can see is that the Finder protocol of the IDS Next Vision Cockpit has found our camera. We will connect it now. Then we can see here the live image of our camera. We have also a gear. And what we next want to do is to install our new app. We go into the Vision App Manager, install our new build Vision app. I have it in the download section here of my PC. I install it. It was only a few clicks. So I can find it here. The new Vision app, Gears Detector version 1.1. I can activate it here, and it appears the new app. Here I clicked on it, activate it, and in the result image I can see here one gear is found. Maybe I put some more gears under the camera, and what you see is, yeah, only the gears are detected as we wanted it when building our Vision app. So our nice little app is now working in the camera and is detecting gears. But what if you want to extend the application, or it might have a bug? I can show you another great feature that is possible with the new software release. Let's say you now want to extend the application. So you want to detect also the dices in the images. To do this, we go back now in our IDS Next Vision Cockpit, because every app created with IDS Next Lighthouse also contains the block-based editor. So the application code is now also available in the camera. To see this, we just open the camera's website over the button here, Open Website. What we see here is the block-based code of the running app into the camera. And to be able to additionally detect dices, I have added only a few more blocks. First, I created a second detection block in the code. And as detector, I used the CNN for the detection of dices that I already used earlier, and that I have also trained in Lighthouse and uploaded it into the camera. To mark the additional dices, I have to draw also the found dice ROIs into the same camera image too. And to do this, I take the ROIs of the dice detection and probabilities and draw this information in red in the same image. And finally, I expanded the text output here with a little bit of copy paste. This could be done very quickly, and that's it. In the IDS Next Vision Cockpit, we can now see the modified application workflow of the Vision. When I now hold the dices under the camera, also these are detected and marked in addition to the gears. And that's all. Modifying an existing Vision app via the new block-based editor is easy and can be done by anyone. You don't have to be a programmer to do this. I hope this brief insight has given you an idea of what to expect with the upcoming software release for our AI vision system IDS Next, and how we want to make embedded vision development with artificial intelligence accessible for everyone. So if you are thinking about trying out AI vision yourself and want to gain initial experience of whether an inference solution is suitable for your application, we recommend our IDS Next Creative Kit. It provides you with everything you need to get started right away. In addition to the complete hardware, you also get the complete software environment, including access to IDS Next Lighthouse to train your first neural networks and to create your own image processing application in camera. Another good resource to learn more about IDS Next and AI Vision besides our website is of course here in the IDS Vision channel, because we have many more webinars and talks about this topic here, which you can stream on demand from the media library at any time. This brings me to the end of my talk. If you have any questions about this topic, you can ask them now or contact us at any time by email or phone. So thank you very much for your attention.